for the, I got some notification regarding recording anyways. Yeah, so you can check in incremental terms that, okay, for these moneyness, things are fine. Then for these moneyness, things are not fine. What needs to be done again? Maybe you can train it again. So I think that should be the approach. And the questions that you're asking are pretty, yeah, they're good. And I agree with all the points here.
Yeah, for the first two, it's some minor details in the code itself. And for my third question is that in the example, the noise is added to the variables itself. So I'm asking, should we maybe try just adding the noise to the Y independent to the axis? That's one approach that we could go. I don't know how much
that achieve, as in what exactly you are trying to achieve by adding the noise. Of course, I mean, I think that should be the next step, and whether you add it to X or Y, what difference it would make. Because essentially, if you're adding the noise to X, you are feeding the X's with noise in your Feynman function, right?
Yeah.
So it will not add much value. So adding noise to Y might add some value. That's my take on this. But I think this should be the next step. Once you like implement the first part, then adding noise should be like additional thing, using which you are checking the robustness of the Feynman model, right? That is what you're targeting to do here.
Okay, because right now it seems like it returns all these sine, cosine, arc, cosine, all the functions, not really the black shows not yet. So that's the next step. I need to explore the deviation from the function it returns.
Stick to that part. Of course, you will get some weird cosine function, polynomial function.
Okay.
You just need to figure out that what's the deviation from the actual black shows and whether it's going, and you can check for, like, you can make some kind of grid. That, okay, for these volatility, for these strikes, for these moneyness, it's close to black shows, but it's not correct to these, the black shows for these moneyness. And then you can train again for those particular cases.
Okay, I see. Yeah. So what you mean is that right now I just stick with the first approach that I in the write-up, basically just run with the generated data with no noise. And next step maybe
let's stick to basic and figure out what's the conclusion for this, and then the next step, I think, rather than adding the noise, I would suggest that figure out for which cases there is a lot of deviation, as in for which strike, for which volatility there's deviation, and try to train again for those cases rather than adding noise. That would be a better value addition rather than adding noise.
Okay. So the other question is that I'm looking at, because the volatility is also, we are using the volatility surface function. So it's also derived from moneyness and time to maturity. I'm thinking if we should drop the volatility or maybe add another variable. It seems that the more variables we add and makes the whole function somewhat simpler, the algorithms works better in that way.
Yeah, I mean, that can be the next step, but dropping volatility, the purpose of doing that in the case study was same as you mentioned. We try to deal with like less number of parameters.
Yeah, it's more complicated.
Yeah, but again, that volatility, I mean, you are assuming some equation when you are making your volatility as a function of your moneyness, right? So there's another assumption which is there. So I would say let's deprioritize this point as well. Of course, there is a value addition in this, that you are able to get the formula with less number of parameters. But I think there's another step that you are adding, that you are making volatility as a function of moneyness, right? So I think you can deprioritize this point as well. And once you are able to reach a good conclusion by the first approach, then you can try this. Of course, you can try this, but this I don't think will add much value, dropping volatility or adding noise, according to me.
Okay. What about the adding variables? If we make the ND1 another variable and feed into the data.
that makes sense because
Okay.
then the equation becomes simpler.
Yeah.
When you're using ND1, then the
This,
Finman, this thing, it doesn't have to do a lot of hard work in
Yeah.
coming up with something like ND1, right? So that
Yeah.
makes sense. So that is something you can try. That's a good one.
Okay, cool. Yeah,
Yeah.
that's my update for next week, not last week, and yeah, I'll do more of the testing, and let's talk maybe in 2 weeks.
Sounds good. Thank you.
Yeah,
And in
thank
case
you.
you want to like update me with any model which is close to Black-Scholes, you can put it in Slack and I can take a look.
Sure. Yeah.
Thanks.
Will do.
Thanks. Aaron.
Thank you.
That's good work. Yep.
Hi, you saw some of the visualizations that were put into the Slack message. So I went back and kind of looked at your message that you followed up on with some feedback. I guess we should have been more clear as to what these visualizations were.
Yeah.
So the one that's titled actions for a specific delta, that's referring to a change in state variable, right? A change in state variable. We define that as the difference from the past stock price for a given window to whatever time period you want, right? So in other words, that's the delta, that's the change in price, right? Percentage change in price. So the graph we have here is we have our user input a specific price change. And that visualization gives back the actions when that price change is satisfied. So in essence, it's kind of trying to mimic or visually mimic that table with buy, sell, hold, and the average percent bips price change that that you defined in the original project charter.
Yeah.
Again, we should have been more clear when we communicated these initial visualizations with you. But in essence, we'll have on the application on the dashboard, right, on the dash application, the user will be able to say, all right, I want like a specific, I want the same table that you have in that project charter for when, you know, we have an increase of 10 bips. What's the percent buy, sell, hold? And obviously the reverse of that. So again, iterative process here, but we just wanted to get kind of a minimal product out so you at least started seeing things.
Right. So let me understand. So what I see is there are 3 charts I see here, right?
Yep.
And so my understanding, and correct me if I'm wrong, so my understanding was the first thing that you are then generating these charts for each episode during the training period.
Yeah, so
right?
Yeah, right. So what we did, so the data set, I have to mention the data set here as well. Instead of building the visualizations out for at the final product will have kind of a trend over episodes, but so using the paper on interpreting Atari reinforcement learning algorithms, they have both an inter-episode interpretation and then an intra-episode interpretation. So this is the inter-episode.
Got it. Yeah, that makes sense. And let me clarify the charts first, then I'll come to the question. So if I look at the second chart, what I see is that it says buy, sell, and hold. Of course, they have their color, the different colors for that. But what I was confused about was that all the points are showing all buy, sell, and hold. So if I don't know whether there's a way to share the screen, but yeah, I was looking at, so let's look at the second chart. In that chart, every point has all 3 buy, sell, and hold. So that is something I was not able to understand why it would happen like this. So if buy is happening today, maybe the sell is happening after 2 or 3 days, then there should be some lag between the buy and sell. So is there something expected? Are you like selling on the same day on which you are buying?
Are we selling on the same day? So I don't think we're selling on the same day. And so to be clear here, the space between points here is when the algorithm exercises an epsilon greedy strategy.
Okay.
That's why you don't see points on specific windows. And so for a specific trading day, right, we plot buy, sell, hold and the respective Q values. To answer specifically why it doesn't alternate between buy, sell, hold, I can't answer that. We didn't alternate. Actually, I can tell you why. Between the buy and the sell, there might have been epsilon greedy choosing to sell and or to buy respectively on the flip. Does that make sense?
Okay, yeah, that kind of makes sense, but I get it now because maybe I didn't look at the chart very carefully. So the first chart is for the buy, sell, and hold, and the second chart is for Q value. You're saying what's the Q value for different buy, sell, and hold, right? And whichever has the highest Q value, that is what will be executed on that particular day. Okay, maybe
Precisely.
my bad.
And so I think this is, again, iterative product here. I think I'm looking at this and trying to explain this in English to you, right? And not in code.
Yeah.
Maybe we should be including which action was chosen by the epsilon greedy, right? Because the first thing you pointed out was, why are we selling back to back without buying anything? That doesn't make sense, right? So maybe we do include, I don't know, let's, so the specifically the day I'm,
You can sell without buying anything. You can, if the shorting is allowed, you can do that. That's
okay,
not
so again, maybe we should be more clear specifically what we're visualizing.
That's I think the next step, as in putting constraint on the model that you can buy first. So that is fine. That's not an issue. So what my understanding in the first chart is your buy, sell, and hold versus time. Second chart is Q value, and whichever has the highest Q value, that is what you are doing.
Precisely.
And then the third one is greedy versus non-greedy. Fine. So yeah, I mean, coming to my suggestion, let's look at like bigger picture here. Let's take a step back. What we're trying to do is we're trying to do some interpretation. Of course, looking at each and every episode makes sense. You get an understanding what's happening, but there has to be some theory around it. Of course, it's tough for enforcement learning. I'm not saying it's very easy. So what you can do is the chart looks good and what you have done looks good. But I would suggest that try to figure out some theory of what's exactly happening as you're training. As the number of episode increases, the code or the algorithm should improve, right? So whether it's improving in terms of it's getting a better return, or it's doing the right kind of trading, that when the price is low, it's buying and price is high. So what's the behavior? What's the theory? What's happening? So that you are able to explain to people that, okay, this is what it's doing and it's making sense during the training process. So that's part one. And I think you are going in the right direction with all the visualization and greedy versus non-greedy and what's happening here. What I would suggest is that you can add some kind of grid saying, you mentioned about price increase or decrease versus buy, sell, and hold, right?
A
So you
percentage
can
of buy,
add
sell, hold, yeah.
Yeah, you can add some kind of grid that, okay, with these percentage of change in the price, the algorithm is buying, selling, or going for hold, right? This kind of grid you can have. And that grid you can change or that you can update it with every episode. And you can check episode 1 versus episode 10 versus episode 100, how it is improving, right? In terms of the buy, sell, and hold. So that's one suggestion during the training period, right? And it might require some work for building that grid, but it might not be very tricky. In case you are stuck, let me know.
We have
And then the second part is basically when you give this model to the trader, they will ask that, okay, I will not be using it for the training period. I'll be using it for some other period. So how does it work in the training period? So that is where the importance of backtesting comes in the training algorithm. So maybe what you do is you feed the model with different kind of data, maybe trending price, maybe a flat price, maybe a decreasing price, and see what algorithm is doing. So once you have the model finalized that, okay, I've trained it for 1,000 episodes, now it's a time to run for some test case. And then you see that what algorithm is doing, whether it's making sense in trending market, flat market, or going market when it's going down. And is there some theory or some logic that you can extract out of the algorithm? So that would be like step 2, if that makes sense. And then we can, of course, talk about a lot of quantitative ideas as in quantitative models to get the interpretability out of the neural network that you're using in the reinforcement learning framework, right? What the final trained neural network is doing that can be interpreted as well.
Yeah,
So
we can go down.
start like step by step. Whatever you're doing is fine. Understand the grid or the behavior of the model during the training process, move to the test, and then once the model is finalized, we can have like a plethora of models or ways to interpret it, especially the neural network that you're using. I guess you're using Q learning, right?
Correct.
Which
Deep Q.
you're using Q learning? As in
Yep.
Deep Q.
Correct.
Okay.
Deep Q.
Yeah, so that has underlying neural network, so that
Yep,
can be
dense.
interpreted.
And so that whole neural, we can go down the Shapley line value path when we get there, or whatever other numerical interpretation we want for the neural network.
Yes, exactly.
So I guess the question, or not the question, right? So the app, I don't want to go too much into the front end aspect of it, but in essence, what I'm seeing is maybe a tab for train, and then for a back test on testing data, right? And then under those two tabs, we have an inter episode and intra episode. So we have two tabs. We have two tabs, and then two tabs under that, and then the respective visualizations. And so for that, this is where the database is going to come in, or my idea behind the database, right? We don't want to be running the algorithm every single time. We want to update or have a callback for a different, a different buy sell hold for, buy sell hold, or, a different time slot. So, and Zach ran it. It took 4 hours to fit 10 episodes on the train set. So I'm thinking once we have it in the database structure that we want, we were just going to host it in one of the various kind of free cloud platforms there are, and then just use kind of Postgres is really easy with Python, so we just use what is it, PySog2 or whatever, and then just import and then just make calls to said database to kind of update the visualizations as needed.
Makes sense. Yes, but you can also optimize it. It might take a lot of time because it's training, but I don't know whether. So you guys are using Google Colab, right? And GPU.
Yeah, and obviously the GPU processor there.
Right. Yeah, I mean, you can maybe decrease the number of.
That's on 10 episodes. That's not on 100 episodes either.
Right. Yeah, you can start with like lower number of episodes or epochs. And
so yeah, so I guess my idea was maybe just build a dummy data set to at least so we can get a proof of concept out in terms of what this looks like, right? And we just use random number generators for respective Q values, and then kind of say, well, we can get the action column for our database or data or test or dummy set, right? By just saying max of the buy sell hold on a specific day, do that. And then once we can build out the tabs and the visualizations, then all it is, obviously this is all modular, this is designed using modules. So then you just plug in a different data set and it'll just push to the respective, places that it needs to be. While, while someone else, so Zach and I've been doing a lot of the back end of the data, and then Ulan has been beginning to work on the app, right? And then it's just plug and chug. So that's kind of my idea with that.
Yeah, that makes sense. So in terms of the database, what are the different databases you're considering as of now, or is it something you need from me? I guess you guys are good on that, or something is needed from me?
Yeah, Zach and I have been having intermittent discussions about it. Zach, chime in here. What was the thing that you said that had I'm not assuming we need gigs and gigs of data. We don't need that per se, right? I'm saying we need a table for train, we need a table for the test, and then maybe another 2 or 3, as you said, you want a bull market and a bear market, and then how does the algorithm work in those respective kind of conditions? And obviously a test and a train with that. So maybe we need like 4 or 5 tables on 10 episodes to start, and obviously we can, once we have more computational power, kind of go with more episodes. But I think 10 is a good starting point, and then figure it out from there. Zach, what was the platform that you said the Postgres was working, that we could have a Postgres running on?
I didn't suggest anything for Postgres. I just suggested we could possibly use AWS, because I know that worked for my capstone, and their free tier should have enough space for what we're trying to do.
Okay. I guess it's fine, and then we'll just not use a Postgres. What DB did you use?
Dynamo.
Okay, so does that have a Python OBDC wrapper?
It probably does. I did not use it though.
Okay,
AWS is pretty extensive, so I would assume they do.
Okay.
I would guess they do.
and we can obviously do more digging, Harry, to get something that is super easy for us to use.
So any input or anything needed from me on this, or you get the?
I think, for now, I think we're gonna dig, and then should we run into a dead end, we'll come back and consult. But I don't think your research are kind of needed with that at the moment. That is.
I agree with you. I mean, having a database is good, but yeah,
Yeah.
feel free to let me know in case you need anything from me.
So I guess from a very 40,000 foot perspective, in terms of development, once we have data in a DB, a lot of that Dash stuff is best done through Git. So we're just gonna move everything to Git. So it's
Yeah.
easy to then just hand over to you when this is all done. We'll give you all the DB information. And I mean, it's literally could just be a plug and chug, or if you have some kind of cloud hosting through Docker and Kubernetes, you could just literally push anywhere you want.
Yeah, that sounds good. And I mean, I'd like to reiterate this point. Okay, I mean, the interface is fine. Interface is something which, of course, will give you a good interpretation, good look into the interpretation. But also, let's focus on the quantitative aspect of the things, as in how to, once you have like the neural network, try to figure out what's happening there. And
Yeah.
basically, the question that you have to answer is that how do I trust your trading algorithm, the reinforcement learning? It's difficult, but then you can go like step by step. On that journey, I would suggest.
Yeah, again, I just didn't want there's two people or almost two, let's call it 2.5. I used half my time, not in full time. So we didn't want people just sitting around. So I said, let's just go start prototyping the front end. Ulan's been good with that. While
Makes sense.
Zach and I do a lot of the heavy lifting on the back end. The back end meaning the quantitative stuff.
So you guys, I mean, you and Jack are working on this, or there are other people as well?
So Ulan, Zach, and I are doing this project. Ulan has HTML experience, but I said just use Dash. It's so much easier, and we're not building some beautiful website. We just need a dashboard, right? So he's working that out while Zach and I do a lot of the lifting on the quant stuff, while Ulan's understanding it, because you got to understand both of it for it to work. So that's kind of I just didn't want people sitting around doing nothing.
Sounds good.
That's everything from my end.
So do we have anyone for? I guess there were like 3 projects which were taken.
Hi, can you?
Yeah, so I'm working on the Bitcoin trading strategy, and just this, Professor Zorro, I don't know if I'm interrupting. Oh, okay. Just this past week, I've been teaching myself HTML, CSS, and JavaScript because I'm interested in trying to build some type of like website or database that can make live predictions for cryptocurrencies. And additionally, I've been trying to replicate your analysis on Bitcoin for other cryptocurrencies. I started one with Dogecoin, but the majority of my time I've been trying to teach myself some of the front end skills to be able to build that server. So I haven't gotten deep enough into the analysis yet to really have questions for you on your end yet, but that's kind of what I've been doing.
That's fine. Some noise from.
I think that was Professor Zorro, but I couldn't make out what he was saying.
Yeah, I just have like one comment to add. So I guess Dogecoin is pretty interesting, and going through HTML and all is good. But I just wanted to check what exactly, in terms of algorithm, what exactly you're planning to do. Are you planning to use like supervised learning or something else once you like work on this?
I think I was planning on supervised learning, but I'm not 100% positive right now.
Okay, fine. Once you're done, or once you have some concrete plan, let me know. You can drop me some note on this Slack as well, and we can brainstorm.
Yeah.
Hey, Harry, I have a quick question. Where is Sela?
Marcel, I don't know.
Okay, so it's you and Marcel on this project, right?
Well, I thought he was leaving. Well, I don't know, because isn't he starting full time?
Yeah, he is. So it's just you then, because I have other students coming from for the fall that are interested in this project. So I want to put them in touch with you,
Yeah,
and I
I
want them to
talked-
start participating.
I remember I talked with one. I'm blanking on her name right now, but yeah,
Yeah, she was in India and she's joining in the fall.
yeah,
So there's I don't know, I think it's so many hours difference, but she was very interested in it. So I want to connect her.
yeah, definitely. We talked briefly, but
Okay.
I'd have to talk to. I'd be happy to
Very
talk.
good. It's all on my end.
I think that's all on my end. 2
Okay.
weeks. Heron, does this time still work in 2 weeks?
I think so, yeah. It's
Perfect.
okay. I think,
Great. Thanks, Aaron.
yeah, enjoy the
See you in
summer
2
breaks.
weeks. Thank you very much.
Yeah,
Thank you.
Thank you.
Bye.